Welcome everyone to another NGA2D video interview series. I am joined today with Mavi Figueres and Eric Hoxit from GrapheneCR, GCR. Now we're here to talk about graphene. Now graphene is known for being black, but what about if it was green? But not the colour green, as in green as in environmentally friendly. Now I invited Mavi and Eric on today because their company is very environmentally friendly focused. So Mavi and Eric, GCR overall has an ethos of being environmentally friendly. So where has that stemmed from?
Well, I'll start and I'll let Mavi jump in a bit since it's her story, but Mavi obviously is from Costa Rica, and Costa Rica has sort of a long cultural tradition of really looking out for the environment and taking care of their surroundings, taking care of the plants and animals that they live with. And it's really beautiful to see that culture and to see how much care they put into taking care of the environment around them. So it really does seem to be something very deep-seated and genuine, that there's value to taking care of the world around us. And I don't know, would you like to jump in on that, Mavi, and tell it?
Well, it all started actually several years ago when I heard about Dr. Weaver and his process. So when I went up to the plant and he gave me the tour and showed me the process, at that moment I fell madly in love with the entire process because it actually comes from trees. So that's how that's where we say our name, that is green. So we don't mine it. We don't use harsh chemicals. It literally is a very, very clean process from the moment that the tree sequesters the oxygen.
The carbon dioxide, right.
Sorry. And then we start that process. We just go through the entire process of right now discussing, for example, with plant forests. So we don't just go and cut trees. We actually have been discussing with many plant forests throughout different areas so we can get not hurting primary trees. I think
more sustainable forestry, using that for our feedstock. So there are a lot of things that we're using as part of our planning as we go forward and we scale up our production to make sure that everything we're doing is being done in the most environmentally friendly way, in the lowest impact way, and really, just keeping the carbon cycle. We're really just sequestering carbon out of the carbon cycle to produce our graphene. It's pretty remarkable, the science behind it. It's very elegant, actually.
I think it's definitely good to hear. There's it needs to be more drive on environmentally friendly process, especially within like chemical. Well, I'm going to say chemicals, but like graphene, chemicals in general, chemicals manufacturing or materials manufacturing. Let's say overall. Now you've because we had some exchange in the past. You've mentioned about your process being carbon negative. For those who are not aware and are watching this, maybe not come across the term even, could you please explain why you have such a low carbon footprint as a manufacturing, and how your manufacturing process is carbon negative?
Absolutely. So one of the really interesting things about our manufacturing process, and one of the ways that it's so different, is that it actually originated as a clean energy project. The company was founded originally to produce hydrogen, to extract hydrogen from biomass. And we've done a lot of work and experimentation finding the most optimum feedstock, whether that's, we've tested everything from, some of the ones that we heard about 10 years ago, switchgrass, and some of these other biomass sources, to municipal solid wastes, to agricultural wastes, to corn stover, and a lot of other products.
Only 122 different products we've tested so far.
Just an afternoon's worth of work.
We meaning Dr. Weaver.
Yeah, we meaning Dr. Sam Weaver. But found that the optimum biomass was hardwood chips. And when I say optimum, I mean for producing graphene and the hydrogen. So to go back to what I was saying a moment ago, that this all started producing hydrogen, which is clean energy. It's environmentally friendly, sustainable energy source, and was doing that to produce both hydrogen for electric generation as well as for biodiesel, converting that into diesel fuel for, you know, like commercial trucking companies. And one of the things that they found was that one of the co-products that was being produced from this was an activated carbon, a biochar that was really wondrous. I mean, it's pretty amazing stuff in and of itself. That the biochar is a fantastic agricultural additive, a soil additive to enhance the productivity in agriculture and reduce the soil or the water consumption in agriculture.
I can literally, this is where I fell madly in love.
Yeah.
100%. When I saw all the different applications, all the different byproducts that you could get from this biochar. So literally the process of it, we can get from 1 metric ton of feedstock, we can get half a ton of water, which then can be, of course, purified with graphene filters once we come up with those, or somebody does come up with those. In the meantime, that water is being used as wood vinegar, and it is a natural
antifungal and
insecticide.
Insecticide.
So it really is a wonderful byproduct by itself. Then we also get the fact that the biochar, if you grab this biochar before the next step, which is graphene, and you put it on big, huge agricultural plantations, like here in the United States, there's huge orange plantations. So you only have to use half the water because it holds its own weight in water.
Right.
So you're saving so much water. On top of everything, it also helps with the plants, the food. They grow 5 to 10 times bigger. It grows 75% more fruit. It is really, really, that is where I fell madly in love. I couldn't believe it. And this is the solution, but we have to get there. So we cannot at this moment where we have to get to the passing the graphene era. And then once all the graphenes in the world, they start lowering their prices and everybody can afford graphene, then we can concentrate on both. We can actually have graphene as well as we can have biochar. So it is to me, that did it. I mean, that's saving our planet, helping heal our planet. The biochar, when you put it on Earth, it literally just brings back all those minerals to the area where you have these big plantations. As everybody knows, in huge plantations, after a while, it takes so many minerals from Earth that then you have to move the plantation somewhere else because they're not that effective. With the biochar, actually, I say it injects back. It literally cures. It helps cure where this big, huge plantation. So it gives back to.
You're talking about Earth. Like the crop rotation, where they don't have to move the crops from one field to the other and leave it fallow every 3rd year. And using the biochar, they don't have to do that. The soil remains productive and active and healthy, even without that resting period.
So when I went and met Dr. Weaver, it was not only the fact that he was producing graphene, he had just discovered that literally 2 months prior when I went and met with him. So it was a wonderful moment to be right there in the birth of his graphene. And then on top of everything, it's biochar, which is so good for the planet. So at that moment is when I started, thinking more and more about it, and I discussed it with my family. The Figueres family is well known for environmental everything. My entire family is always involved in our climate and assisted helping, by the way. So I came back and I talked to my father and I told him, I don't care what we do in life. This is what we need to get into because it's going to be so good for our planet, for humanity, for everything. And on top, it has graphene. I mean,
so the part that we didn't get to say yet was that this biochar was highly graphenic, just right out of the gate, so to speak. So the carbon biochar already contained 30-something %.
34.
Multi-layered graphene They had it analyzed at University of Tennessee, and he calls that his Christmas surprise, that they did it over the Christmas break one year, and found out that, in fact, one of the reasons this biochar had such miraculous properties was that it was already contained some graphene. It was already broken down into the graphene-sized particles. So what they've done now is, really just spent the time and figured out how to further refine that into really high-quality graphene powders. So we have a graphene nanoplatelet, which is sort of a one-step refinement from that biochar, and then a further step to really refine it into a good, high-quality, consistent graphene powder that's it's really showing some promise for commercial applications. We're seeing really good results using this. And so in addition to being, sourced in a green and sustainable, eco-friendly way, the other thing that's really exciting is all of the benefits that it brings to whatever application it goes into, whether that's, enhancing the lifespan or the useful life of, different materials, composites, and so forth, lightweighting for other, you could say automobiles or aircraft or whatever it is. Yeah, absolutely. Super lubrication, super lubricity for enhancing engine efficiencies. That all translates into less energy, less emissions in the long run. So, it all really flows through. And it really does come back to that core mission of GrapheneCR, which is to heal the earth. We want to use graphene and graphene technologies to leave the world better than we found it.
It sounds like you got a very circular process. Let's say you take from and you put back into it's a very circular process, and alongside obviously the added environmental benefits of the end products as well. The longevity, right. the less material, the longer useful life, those kind of enhancements, which obviously means less material being used and being spent and going to waste.
Yeah, so, we're almost a closed circle when it comes to the carbon negative. Yeah. We're missing one tiny little element, is the trucks that bring the transportation that bring or take the graphene. They use diesel. So we're almost at a closed circle, because soon those trucks will be either electric or will use bio. So we literally are at a closed circle. We, the same graphene, the same process produces energy. There are, next to one of the plants, there's this huge, they have, they call it the solar plant. And so they use the solar energy to move to just have their machines going. So they're literally using everything green. So it's wonderful to see. Yeah, it is wonderful. It's going to the plants, either one of them. It's always a wonderful, because it's everything about the green and the good. And they're actually now talking to the IA because of what they're doing with our graphene. So we're going to actually implement that potentially in the cement and concrete and for the
different building materials.
The different materials, yes, because they need for the floors to be clean. And so it's good to see what's happening with all of these other companies that we're starting to talk, and it just kind of starts going out and out and out, and everybody's related. Seems to me that we're getting married with a lot of people in a lot of companies. I'm very notorious for proposing. I propose to everybody.
As a company, seem very switched on with the environmental aspect. But if we look at the industry as a whole, beyond what you're doing, do you think more could be done within the graphene industry to make the processes greener? Because obviously you mentioned there's a lot other processes, like with the mining, the harsh chemicals, and it's just the nature of a lot of manufacturing and fine chemicals and materials that they're not known to be the most environmental processes. So could more be done, do you think?
Absolutely. I think that there's a lot that can be done, and I think it will be done over time. But it is a relatively new industry, and so right now the efficiencies and proving out the technology and making these commercial applications and the commercial breakthroughs, we have to make it a sustainable industry from a business point of view first, and then we can continue to refine it and find other ways to make it more environmentally friendly and sustainable. we're going to continue. I mean, if you think about, gosh, Lee, you probably know this better than nearly anyone. The advances that have happened with graphene and graphene technology in the last 15 years, it's remarkable what's already happened. So to think about what's going to happen in the next 10 or 15 or 20 years, we're going to see some really, really cool advancements all across the board, from the way that graphene's manufactured to the way that it's used and applied to different industries. So absolutely, I think there's going to be a lot of potential, and I think it's inevitable. I think nearly every industry is going to move, some more incrementally, and some are going to move in leaps and bounds. I think graphene and 2D materials really does have an opportunity as an industry to make this a focus of what we're doing, because some of the benefits really do apply so directly to looking at environmental benefits and sustainability, and bringing those benefits into the other industries with which we interact. So I mean, whether that's, again, I keep saying, you know, automotive, but I mean, also think about personal electronics. We see a lot of research happening with graphene batteries and supercapacitors, and, you know, just general energy storage.
I mean, we came up with a product that we're calling Pellegraph, and it is literally graphene infused pellets made of whatever polymer. So we would have PP, polyethylene, polypropylene, recycled, virgin, PET.
High density, low density, yeah. I mean,
absolutely. So we started doing these tests, and the results came out quite nicely.
Yeah.
So we have been already sent it to the different areas in the world to be tested and to see if the different groups, one of them, for example, that I continue telling everybody, imagine coolers. I'm sorry, but
yeah,
I have a thing for coolers. And so imagine if we can add the graphene to the pellets, you know, producing these coolers. So those are the things in the cars, the dash, every plastic part. If we can add graphene, the beautiful part of that is it is not going to make the plastic biodegradable. We know that, everybody knows that. But we do know that at least any graphene that is in any plastic that at one point in its life is going to go to the landfill, the graphene in that will go back to that landfill, to the earth.
So as the plastic breaks down, it
will help heal. It's not a band-aid exactly, but it will help with the healing process of wherever the landfills are. So when we start adding graphene to all these plastics and all these polymers, it will help at one point kind of not be as negative to our environment.
And the other part of that, yeah, the other part of that with things like plastics and plastic recycling that we're learning is that obviously plastics are getting sort of a bad rap right now, and deservedly so. There's far too much of it that's being discarded irresponsibly and ending up in places where it shouldn't, like the middle of the ocean. Mm-hmm. But a lot of this is that plastic, it's just not feasible to do effective recycling for it. That, you know, the life cycle, it becomes brittle after, you know, 1 or 2 cycles. Well, it looks like the early research is showing that, you know, a small graphene loading to some of these can not only enhance, you know, the structural strength of the material and make it perform better, but also can help it to be less brittle as it's recycled more and more. So we can get a longer useful life out of these products without having to create more and therefore reduce the waste that ends up places where it shouldn't. So I think that's another really cool benefit. We
call it rejuvenate.
Yeah.
As you know, everybody tries to get younger. We're trying to do the same thing with plastics. Give it an extra life.
Well, I think regardless of, I think plastics are going to be around as much as they are bad. They've become like a staple in modern life, so they are going to be around. So if you can improve them, obviously it doesn't solve the issues, but it helps, obviously, with some of the issues of plastics. So obviously you're environmentally conscious, like both you and the company. From your point of view, from like a company perspective, would you like to see more companies like adopting like a greener approach like what you've done, or is that something you would like to see?
It would be wonderful. It would
Yeah.
be great for our planet. I don't believe in competition, by the way. So when I say things like that, everybody says, well, it's your competition. And I just don't believe in competition.
Okay.
I truly believe that if we work together, just imagine where we would be if we all work together instead of against each other. It would be a beautiful thing to see humanity take that next step instead of everybody fighting against everybody, you know, just trying to, oh, it's mine. So no, I believe that it would be beautiful to see other companies and other groups being able to do more environmentally friendly. With that said, we cannot give the process because we don't own it. And therefore, if I own it, I actually share everything. I'm a big sharer. And so if, for example, the pellets that we are producing, because we are producing them, I have no problem. And I do talk to other companies and tell them, do this, you know, don't do this. And all the especially every time that we hit that wall.
And the same thing with some of the liquid dispersions and other things as well. Yeah.
So what we do is I like to share and help others. Don't make the same mistakes we did. Let me tell you our mistakes, because you might hear or do something that we didn't. And so you don't have to start from scratch. You can actually move forward. So I believe that if we all were to work together for that goal of bettering and healing our planet and bettering humanity, we would be in Mars much faster. Sorry. But I do believe that we do need to do a lot more as humans to concentrate more on healing our planet and going more green, that the effort that we're presently doing. We have run out of time, and I do believe that all of us need to do a bigger effort. There was somebody once told me, well, it's only me, so who cares? It's only one bottle that I'm throwing away, so who cares? There's 7 billion people thinking the same way. And therefore, we need to change the mentality of all in the planet, because one person does make a huge ripple, and they don't know the effect. So it is very important that other companies, it would be very important that other companies also start seeing the good part of being green.
Yeah. So the collaboration mentality of that is obviously quite important, because you could quite easily just keep that as like your USP and just to yourself, it's like we're greener than the others. But obviously the collaborative mentality obviously opens that up to more shared discussions and shared information and knowledge, which obviously helps everyone. And obviously we've talked a lot, and we've mentioned here about different applications and different industries, about using graphene to make the greener, like we talked about the construction and the concrete, and Eric's brought up about the automotive and the aerospace, and the saving on fuel and on lightweight and all those sides. And there's a potential there for graphene to make a lot of these industries and applications much greener than they have been in the past. So like how true do you think like these words are, and how much potential is there for graphene, like to revolutionize these applications in terms of making them green and environmentally friendly?
Man, I think it's pretty limitless, and I mean, maybe I'm being overly optimistic, but we're so passionate about this. I mean, really, if you think about, just take a simple application. Let's go back to the automotive, right? So if you could lightweight a car, let's just say an internal combustion engine car. If you can lightweight 10 to 15% of the weight of that without compromising the safety or structural rigidity or the body performance, if you could have a car that performs the same without 15% of the weight, what does that do to the efficiency? So what does that do to the gas consumption? Now transfer that over to something like EV technologies, right? Well, what does that do to the range? So I mean, when we're looking at those sort of things, when you look at how the efficiency that graphene can bring to these applications, when it flows through the way that they work, it's absolutely remarkable. I am convinced that graphene is going to be ubiquitous. It's just a matter of time. it's not going to be something that we think about and that we talk much about graphene this or graphene that. It's going to be, you know, sort of the same way that we see the other things in our made environment. You know, we don't think much about, well, which type of plastic is the air conditioner grill made of? Mm-hmm. It's just a plastic piece. It's going to be the same thing with, you know, the components that make up all of these different technologies, whether that's, you know, coatings or insulation, you know, all the different building materials, whether that's, you know, a better concrete that takes half the material to carry the same load or even less. There's really remarkable work being done with concrete and graphene.
We didn't succeed the first, the second, the third time. We are now working on a fourth.
Oh, that's right.
We're
that's
working
really
on that. We have
tests today.
Yes, today they're doing test. IA is in Resina. They both are working on implementation, being able to suspend it and for it not to sit at the all the things that we didn't succeed in, they're trying to do it today. They were very positive. They called us last night for that. They also came up with a wonderful material to be able to suspend the graphene in asphalt.
Yes.
So we have literally now have the product. We have sent it to Costa Rica to be tested. It is there. Yesterday it arrived there. So all of those things are going to be very helpful because, of course, in the road industry, for example, it is so hot. So when you're pouring it is so hot. It seems that there's a 30% less heat coming up. So when you're pouring it, the people, did I not say, I'm sorry, asphalt. Yeah. So the people don't get burnt and they don't get, it's so hot. So they don't get burnt and either chemically, it helps to reduce that. So the applications in the asphalt are really amazing, and we are speaking to governments in different countries, sadly not in the United States, but other countries are willing to do the tests without charging me. So I am not quite upfront, at least. So we are doing those kind of tests, but we have construction now, and I have a weakness for construction. I feel that has been my concentration from the get-go. I want to concentrate on construction because it is something that is never going to stop. And therefore, the better that we can do our houses, the safer for our people, it's the better, again, for humans. It's better for us. And it also helps environmentally. So we are doing, it's a whole cycle about environmentally friendly houses that are safer and better for us humans, and at the same time we're taking care of the trees in our green areas. So I'm very, very happy with what we're doing in construction and in asphalt, and I'm hoping that the result that we're going to get this week with the concrete are finally going to be, we have talked to everybody about concrete, and I have hit that wall so many times. It's amazing. It's so embarrassing, but I mean, I sit and cry and go, why? And then we have to do it all over again. And we just keep going. You have to keep going. You cannot stop.
And if I think it is, it does seem there's a lot of so many different areas, and you've outlined a few, and they're obviously just a few of the many, let's say. Yeah. But if we're looking at your process now, and we'll wrap it up with a final conclusion on it. You've obviously so far done a lot of work into making your process green, environmentally friendly. Yes. You've mentioned obviously previously earlier on about the trucks, and that's the one sticking point. I could say, are there any plans to expand on what you've done in terms of making it environmentally friendly? And is there any way you can improve the processes further to make it more green, or is it green now and it just requires these extra external elements?
Well, I think that to make it more green, as you just said, I think that we could improve simply in the power base of these huge plants. They're very, very large plants, and therefore I feel that if we, which we will, add more wind, Even if there are any of there is one of them, river, Costa Rican size. Yeah, Costa Rican size rivers, not United States size rivers. US, they call our rivers creeks, which is quite insulting. But, you know, even if you have a small river for our standards, you can actually do hydroelectric power. We can use sun, we can use wind. So we can do all three to be able to power our plants better and more efficiently. And I think that that would be a next step. With the trucks, it will have to be either using biochar or the trucks themselves to be in the very future, they will be electric trucks. So I'm hoping.
Or hydrogen.
We've seen
a lot of different technologies.
So it is going. That's the last part to finish that cycle that we have that we're going to be missing, and we don't have power over that, but the world is getting there.
Well, not only that, the other thing I was going to mention, also continuing to look at other feedstocks. We've looked at a lot of agricultural waste and you know, different biomass that can possibly be used, and it's just a matter of either tweaking the preparation of these materials or tweaking the way that we process them. But there are a lot of opportunities for us to do that and use materials that, you know, may otherwise not have such a positive effect environmentally, and for us to be able to sort of refine what we're doing that way. So there's definitely opportunity. The good news is that obviously the transportation is much less than when you're having to, you know, ship graphite all over the world from one part of the world to the other. That's, you know, pretty heavy carbon footprint just in that process, you know, without any of the other parts of that process to refine it. So, I mean, we're already a few steps ahead and really confident that what we're doing is already making a good impact. And it's really encouraging, actually, to just see that, you know, by continually just incrementally improving a little bit here and a little bit there, improving the efficiencies of it, I think there's room to, you know, take a good thing and make it even better.
It sounds like you've already, already done a lot, and there's obviously more to come. And obviously, the wider impact will be the industries and the end use and the applications as well beyond the processes. So it does sound, obviously, from the conversation, from what we know going around, that there's a lot of potential, you know, to take graphene from black to the green, let's say.
Absolutely.
Yeah, one of the things that we have calculated already is that we are setting up, we have been looking at the different areas to set up the plants here in the United States. So we have 3 plants right now in the US, and then 3 plants producing from 150 to 1,000 metric tons per month. So if I get an order for 1,000 metric tons, I know that we can actually produce that per month. But beyond that, the beauty of this is that it's something that we can grow very easily and very fast.
Yeah.
But what I'm even more concentrating is also wherever we're going to put these plants, whether it's here in the US or only in Costa Rica. So we've been looking at areas where there are the plant forests already. So we actually put the plants closer to the area so that the transportation of the lumber is not as, it doesn't have that huge. So anywhere in the US, we are going to be looking at those as well. So as we grow, we will be very cautious about where we put these plants in relation to the feedstock.
As well, the other thing that I wanted to mention, you know, we're not the only ones doing this right now. We've seen some really cool research happening, and especially I wanted to point out the work of, you know, I think everybody knows Dr. James Tour down at Rice, doing really cool work, looking at ways to repurpose biomass, and I think they're calling it flash graphene there. So I know that they're really early stages in that research right now, but it's also really exciting. And so, you know, we're very impressed and hope that we'll be able to find ways to collaborate with folks like Dr. Tour as well. We think there's just such potential to make graphene an even greener technology than it is now.
Yeah, the flash graphene process itself is being commercialized by Universal Matters with James Tour and Beyond the Air. That's a whole different story of environmental green processes that probably that's not to get into today, but that's a whole other aspect on the process side of another green manufacturing technology for graphene. So like you said, not the only one, there are ones out there, so it is there are more coming, let's say, and there are more people using graphene in a sustainable way, so it is good to see. So we'll wrap that all up there. So I'd like to thank both Eric and Mavi for joining me today. I've been Liam, and until the next NGA video, goodbye and thank you.
Thanks, Liam.
Thank you. Ciao, ciao.